Today I'm going to look at series. Yes, so previously we looked at sequences, and we say that a sequence is an ordered list of elements, yeah? So now a series is basically a summation of elements in a sequence. So let me say, given a sequence, A of n, let me say A of n is equal to n. Then n is equal to 1, 2, 3, 4, and so on, yeah? Then a series is a summation of these elements. N plus 2. Yeah, okay. The general notation is, let me say this is the sequence. And the series, it is sigma, I think, of A of n, yeah, from n is equal to 1. It's an infinite series, so to infinity. Yeah, so what you're going to look at now is convergence and divergence. So before looking at convergence, we're going to look at what we term as partial sums. So partial sums are basically like, let me say a sequence A of n is equal to 2, 4, 6, 8, 10. Yeah? So the sum of the first, let me say 3 terms. It's the partial sums of the first 3 terms, yeah? And the partial sums of, okay, so S of 2. This is an arithmetic sequence. Because there's just a common difference between that, which is 2. Yeah? So S of 2 is basically 2 plus 4, which is 6. Yeah? S of, let me say 4, is the sum of the first 4 terms. Yeah? This is 10, which is 18. Is it? This is 20. Sorry. Yeah, so now this is of a sequence. So now we go to terms in what? In a series. Convergence, a series convergence, if its partial sums what? If the sequence generated from its partial sums converge. That makes sense. And it diverges if the sequence of its partial sums diverges. So I'm going to look at a few examples. Yeah, so I'm going to look at 2n from n is equal to 1 to infinity. Or another concept I've forgotten is infinite and finite series. An infinite series is summation of elements in a sequence that are what? That are limited. And an infinite series is a summation of infinite terms, like unlimited terms, yeah? However, an infinite series can converge or diverge. Yeah.
An infinite series
Can converge. Can also diverge. Yeah, so A of n, it's 2n, so the first term will basically be, this is the sequence, so first term from n is equal to 1 is 2, it's 4, 6, 8, 10, so on. So S of 1 is equal to 2. S of 2 is 6. S of 3 is 12, and S of 4 is 20. And so on, yeah?
So,
Yeah? Yeah? 2 plus 4 plus 6 plus 8. So then for n is equal to infinity, the partial sum for infinite terms, it will be what? It will be infinity. So intuitively this, you see that it just keeps on increasing, so definitely it's diverging. Yeah? So now we generate a sequence for the partial sum, which is 2, 6, 12, 20, and so on. And so you see that the what? Okay, here the difference between these is 4. Here it is 6, here it is 8. So you notice that it just keeps on increasing, so definitely it's not converging to a certain finite value. Yeah, so here we conclude that what? This sequence, sorry, this series is divergent. So I'm going to now look at arithmetic and geometric series. These are basically the most common types. Yeah? So an arithmetic series is one whereby there's a common difference between the terms. Let me say an plus 1 is equal to a of n plus, let me say d, and d is denoted as the common difference. So the sequence, the series that we looked at previously of 2n is a what? An arithmetic series. Yeah, and getting its sum, the sum of n terms. It has two formulas. You can either use a, the first term, that's a of n, minus n over 2. And then second one is n over 2 into 2a plus n minus 1 times the common difference. So if you're given any, if you're required to find like the sum of n terms, whereby you're being given like the common difference, usually use this. And if you're given the last term, that is definitely a what? It's a finite series. Even this can apply for finite series, but most commonly we prefer to use this. Here's an example. So there's an example. We're given the first term, A1 as 5, and then inside the 20th term as 62. And we're required to find the sum of the first 20 terms. So you do notice that you haven't been given the common difference. Yes, so the sum of the first 20 terms, let's substitute 5 plus 62. N is 20 over 2. This is 10. Say 67. So sum of the first 20 terms is 670. Another example we're given, but what's that? Let me see a sequence. Next example, we're given a sequence. Excuse me. And I say 2, 5, 8, 11. So, and as we're required to find the sum of the first 20 terms. Then here we can find, we're given the last term, so we're going to assume that it's an infinite sequence. So first term A1 is equal to 2. The common difference is 3. Here then n is equal to 20, since we're finding the sum of the first 20 terms of the series. So the same thing, just substitute. Which is n is equal to 20 over 2. So 2 times 2 into 2 plus n minus 1, 20 minus 1 times the common difference, 3. That's 39, sorry. It's 19 times 3. It's 61 times 10. Yeah?
610.
Yeah, so this is the sum of those 20 terms of the series generated from this sequence. Just look at the GP of start from the